The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Yeah, hello, good afternoon, everyone. Anyone can please confirm me that my screen is visible or not? You can put it in chat box or you can raise your hands. Yeah, I hope my screen. So good afternoon, everyone. So we are together here for the motion model programming itself. So basically in this today's webinar, I'm going to tell you the one thing that is the related to the motion model. So this motion model, it is working with the MRJT, our servo amplifier. Okay, so in that sections actually there are two options. Either you can use it with the MRJT also, either you can use it with the MRJ5 also. So in this ongoing session, I will tell you the some basic informations related to the motion model, how to use the motion model, which type of programming we can do, which options are available for programming in the by using the motion model, that I will tell you. Also, how to do the system configuration, parameter settings, and how to write the program in a simple motion tool. Also, I will show you some of the operations just like the servo on operation, jog operation. Okay, so as per our time limit, I am just trying to complete everything in this our time limit only. So in the ongoing session, if you have any doubts, any questions related to this, so you can just put your questions in a chat box or you can raise your hands. Okay, so good afternoon, everyone. So we'll start our session. So first of all, I just wanted to introduce myself that I'm Miss Saili Kakade from Mitsubishi Electric India Private Limited. So here we are taking care of the all the training activities that is related to the all the product training activities of Mitsubishi. So we are together here for a MRJET with us motion model programming. Okay, so we will start our session now. So in the session, if you have any questions related to this or any issue, if you are not able to connect again, then please put your questions or any concern is there, please put it in the chat box. Okay. So thank you. So we will start it now. Okay. So first of all, see, we are working with the servo amplifier. So either we can use a MRJT or MRJ5. But the thing is, we are working with the MRJ amplifier. So in that case, you can use a motion model. That motion model, it is nothing but the RD78G dash in the sense there are some of the accesses are there that are inbuilt with this card. Okay, so as per our requirement, we have a different cards are available. Okay, so that in detail we will see in this session. So first of all, these are the contents like product lineup, system configuration, motion control software, how to use that software, how to do the parameter settings of it, that everything I will tell you. Then servo on program, jog operation. So these things I will complete in this today's session. Okay. Then how to do the programming in the another language also, like in the ladder also, like in the ST language also, that I will tell you. Okay. So as of now, we having a motion model that is a CC Link IE TSN based motion model it is. So first one is the RD78GH is there. So it is nothing but we are going to use for a high speed. But the thing is right now we are using the motion model that is the RD78G. So might be we having a RD78G4 is there, RD78G8, RD78G16 is there. Okay, so we will see now. First of all, we will see the introduction part of this one. So why and where we are going to use this one. So if you see, this is nothing but our RD78G4 model it is. This is our CC Link IE TSN best motion model. So this motion model purposely we are going to use for a very high speed large system by supporting the CC Link IE TSN network. So by default, it's a real time open network. Okay, so basically, see, this is control the linear interpolation also by using the functional blocks. The main thing is in the whenever we are going to use the RD78G4 model, so this model it is having its some built-in functional blocks are available. So whenever you are going to do the programming by using this motion model, so there are some options. Either you can use a buffer memory, either you can write a programs, either you can write a program in a ST language, either you can write a functional blocks. But the main positive thing is this model or this function which is having some built-in functional blocks are available with it. Okay, so connected to the various models such as a servo amplifier and input output models via the CC Link IE TSN, that is possible with this. So this connectivity is allowed to configure a servo system more flexible. Okay, so because of that system we are going to use the RD78G4 model. It's here. Now we will see the product lineup. So as I said, like we having a different models are available. Like for a high speed, we have another different model is there. That is nothing but the higher speed control model itself. Another side, like we having, we are using the motion model. That is nothing but the RD78G4 model is available. RD78G8 model is there. 16 and 32 and 64 is there. That means by using these models as per our application need, we can use these different type of models and we can control the number of accesses by using this motion model. So this is nothing but like we can say by using this model only we can do the programming, we can do the jogging, homing, positioning, speed control, torque control, positioning, then synchronous control, cam control. This number of features are there. So that functions we can able to control by using this motion model. Okay. So now if you see here, this is nothing but our RD78GHV and GHW model is there. It will be coming soon. Another side, we having a CC Link IE TSN base model, that is the RD78G4, G8, 16, 32 and up to the 64 models we have. So probably these models comes under the R series. So that's why with the R series PLC, we can able to connect the RD78G4 model here. So this is a CC Link IE TSN best model. So maximum up to the from 4 to the maximum 64 number of accesses you are going to use or you are going to control by using this motion model. And the main thing is whenever we are going to use this motion model, so purposely we need that once dedicated some software is there. That software is nothing but the motion control function tool is there. So with the help of that tool only we can do the parameter settings, we can write a program in ST and other functions we can write it with the motion control function only. Okay, so that we will see in the next slide. Now first of all we will see the system configuration. So in this system configuration, if you see, like we are having our engineering tool, that is nothing but our GXWorks 3. Another side, our PLC is connected. So by default, this model, it is this motion model. Right now we are using that is the RD78G4. So that's why that R series model, it should be connected with your R series PLC. And it is depends, like it is a 4 axis, 16 axis or 32 axis it might be. So as per that model availability, it is going to control the number of axis. So number of axis you can see there are the different like servo amplifier 1, 2, 3, 4 are connected. So as per in this manner we can able to connect the different field devices also in a same common network, and that common network it is nothing but our CC Link IE TSN network, because our RD78G4 model it is nothing but a CC Link IE TSN network supportive model itself. Okay, so this is a system configuration. So in that also we can do some master and local communication. So under the local we can able to put it our other field devices also. Okay. Now This is a motion control software. So first of all, we need to understand whenever we are going to use a motion control model is there now. That is our RD78G4 model it is. So whenever you are going to use, it required a motion control software that work with our GXWorks 3. Okay. So whenever you are having this software only, then only you can able to do the some parameter settings and other required settings in the motion control unit only. Okay. So you can see here, this is our SWM78 motion control software is there. It can perform the motion and the network control through Visual C++. To perform the control, install the so we have to install the software on our industrial PC with a real-time operating system. So probably this dedicated software we are going to use for a motion model configuration. Okay, and this model this software it is always work with our GXWorks 3. Now here you can see the system configuration. Again, I must say this is our industrial PC is there. Another side, different number of models are connected or different number of field devices are connected, different number of servo amplifiers are connected through this our motion model. Okay. Then we will see the some of the specifications. So like we are having a motion control model is there. So that model comes under the Melsic IQR series. So right now we are focusing on this RD78 G4, G8 models we have. So from the 4 axis to the maximum 64 axis we can able to control by using this motion model. Okay. Another side we are having a motion control software is also available. Okay, so maximum operation cycle is 62.5 microsecond. Communication speed is nothing but the 1 Gbps, and by default it is TSN network supportive model itself. And environment, you can see engineering environment. So as of now, whenever you are going to work with the RD78 G4 model, then this model it should work with the GXWorks 3 only. Okay, and programming methods. So you can see in the programming method, like we are having the ladder diagram is there, then FBD is there, FBD ladder is there, or struct ST is there. So basically, whenever you are going to write the program in a GXWorks 3, either you can use functional blocks, either you can use a ladder, either you can use a ST language. But dedicatedly, if you have a different motion model function is available, so in that dedicatedly ST language programming we need to do. Okay, so that also I will show you. And these are also some of the remaining functions are there. Like we are focusing on RD78G model it is. So you can see the control method. So by using that model only, we can do the position control, speed control, synchronous control, cam control, torque control. So these operations we can do by using this motion model only. Another side, the positioning control criteria, you can see the linear and circular interpolation is possible with this RD78G4 model. Okay, acceleration, discretion, we can do the process, then jog operation, also jogging, homing, then positioning. These things we can able to achieve by using this motion control model. Okay. Now, these are some of the features that are related to the CC Link IE TSN. Now here we will see some of the program example. So in these program examples, you will see the structure. One is our GXWorks 3. So always that GXWorks 3, it is working with the motion control setting. Okay, so that tool availability should be there. Then only you can use the motion model. Okay, so GXWorks 3 plus motion control setting tool we required. Another side, our R series PLC, then R series motion model. That model should be RD78, G4, G16, G18 and whatever. But it comes under the R series only. And this is our power supply. So first is, as you know already, like we are having a one common base rack. On a base rack, first slot is always dedicated for a power supply, then CPU model, and then from this slot we can able to put any input, output or any other intelligent model over there. Okay, so right now we are putting here motion model RD78G4, and with the help of that model only we can able to connect the another servo amplifier through the Ethernet. That means this is nothing but the CC Link IE TSN network. So another side, whatever MRJ5 is there or MRJ80 is also there. So on that servo amplifier, the Ethernet port you will get it there. Okay. that port, it is nothing but it will create a network of the CC Link IE TSN network. So if you see that Ethernet cable, this is nothing but our Ethernet Cat5 cable it is. Okay, so this is a system configuration. Now, next thing that we will see the software and firmware requirements. So please ensure that whenever you are working with the motion model, so first of all, you need to understand, you need to see the which RD78 model you are using, which GXWorks software you are using, which motion control setting tool you are using. So every time we need to check the version of that particular software, firmware version of that hardware also, that we need to check. Okay, so please remember, whenever you are working with the GXWorks 3 by using this motion model, then the GXWorks 3 version should be 1.060 and or later on. And the motion control setting tool, it should be the 1.005F or later on. So, and another side, MR configurator 2 is also required. Why? Because of right now we are using the RD78 model, that motion model, that is okay. But there are some features or there are some like parameter settings also we need to do through MR configurator. Okay, so whenever you are opening the window of the GXWorks 3, so in that, from the one of the setting, you can jump to the motion control setting, and from that motion control setting also you can jump to the MR configurator too. So probably these three softwares are working together in that scenario. Okay, so every time whenever you are working with the motion model, please ensure that which software version you are using and which firmware version you are using. Okay. Now here it is, we will see how to create a project. So this one is the procedure only, but I will show you directly on my screen. So just give me a second, I will show you here. Okay, so this is our GXWorks 3. Okay, you can see here I'm using the updated version of the GXWorks 3 only, because whenever you're working with the motion model, then please ensure the GXWorks 3 and motion control setting tool, it should be a updated version should be there. So right now, here I'm having a one system. So in my system, R series R16 CPU is available, and another side RD78 G4 model is connected, and another side MRJET is also connected. Okay, so here we will create a first one new project. So project. So here we have to select the series. Right now I'm having a of me. I'm selecting programming language is ladder as it is I'm taking, then make it okay. Okay. Fine. I hope everyone is totally aware about this, our actual GXWorks 3 window. Okay, so now here you can see the R16 CPU is coming here. Now, first of all, our task is we have to do the connection test, and after that we can do the model configuration. So USB is connected, PLC model is connected, that is a R series PLC model it is, and there is no specifications, and here it is test. So first my task is I have to check the PLC is successfully connected or not. Make it okay. Now my second task is we have to do the model configuration here. So I have to go to the model configuration. Make it okay. Okay. Okay, so in the stage that R16 CPU is coming, so I will just go to online because the system is connected with me here only. So in the online, we are having a read model configuration from PLC option is there. I will make it yes. Okay, so you can see the power supply R series PLC, that is the R16 CPU, and this is the RD70 G4 model is connected over here. So first of all, we have to fix the parameters. After that only we can do the parameter settings for this motion model. Okay, so just make it right click on it and go to the parameter and then fix it. Make it yes, yes. Okay, so now after fixing the parameters only, you can see that RD78G4 model is coming here. Okay, and you can see the starting address of that model. It is nothing but it is start with the 0. So always whenever we are going to use the motion model, we have to check the starting address also, because first on a first priority we have to do the program for the servo on, so that bits required are there. Okay, so we have to check the motion model's starting addresses also. So now if you see here now, this is our RD78G4 model it is. So under that we are having a three options. One is the model parameter, another it's a network configuration, and third one it is a model extended parameters. Okay. So now here we will see one by one. So this is nothing but first one, it is a model parameter. So in this model parameter, you can see the settings that model extended parameter storage location is there. So right now I'm not using any SD memory card. I'm just using the built-in memory. So we are going to select a motion model with a built-in memory. Okay. Then check. Okay. Then second tab of the model parameter. That is nothing but the network configuration. So I'm just going to open the network configuration. So in this section, we have to do the setting for our like station type, which station type it is, what is the IP address of that station, and what is the station number of it is. Okay, that we need to assign over here. So first is, you can see this is a master station. Network number is the 1. And whenever it is the master station, then by default station number, it should be 0. And IP address is the by default 192.168.3.253 itself. Okay. Then just make it check. So fine. Another side, see, this is a basic setting. This is a required setting. Another side, in the basic setting, you will see in the basic setting, we are having a network configuration settings are available. So this is our main task to do the network configuration settings. So whatever the field devices are comes under our TSN network, that field devices need to come under the one common network. That network we have to configure here only. Okay, so just go to the detail setting. Okay, so this is a network configuration window itself. So if you see this one, it is my master station. That master station, it is nothing but the station number 0. That host station number 0 is coming here. Okay, now here we have to configure our network. Okay, so what is our another side, another field device is nothing but the servo amplifier. So that is you can able to file in this model list. Okay, so in this model list you can see GOT is there, motion model is there, general purpose inverter is there. So many field devices are there, but after in that we have to choose our general purpose AC servo. So if you click here now, you will see MRJ5 is also there, MRJ80 is also there, that MRJ80-G is there. So it is depends like which JT or which MRJ5 you are going to connect. So right now in my side, MRJ80-10G, that model is connected. This model is nothing but the single axis supportive model itself. So I'm going to select the MRJ80-G and just make it drop here. Okay, so in the real scenario, this MRJ80-G, that is nothing but the -10G, this model is connected with my setup. So I'm choosing that one only. So you can see the station number of this servo amplifier, it is nothing but the station number 1. This is denoted as a remote station type, it is the remote station. By default, in that you will see the read and write devices are there. So in that by default 24 to 20 number of read write devices we can use. But if you wanted to increase or decrease it like as per your application, we can do that changes. Okay. Another side, if you see, there are two things. This one is the parameter automatic setting is there and the PDO mapping is there. Okay. if you go further, then you will see the IP address of your servo amplifier. So right now, IP address of my servo amplifier, it is 192.168.3.1. So if you wanted to change the IP of your servo amplifier, so you can change it from the motion model tool, or you can change it from actual hardware. Okay, so on a hardware also, they are just giving the two options. Like they are just giving the two switches are over there. So with the help of that switches, you can able to change the IP address of your servo amplifier. Okay. And now here it is, you will see this is CC Link IE TSN class B supportive model it is. So it is by default, these things are coming over here. Okay. So these are the basic things only. Now in that, first thing is we have to do the parameter setting. So before going to the parameter settings, you will see there are two major things. One is the parameter automatic setting is there and PDO mapping is there. So always first task is nothing but the PDO mapping. So what is the PDO mapping? It is just, you can see PDO mapping, it is nothing but the mapping of your devices, whatever the data you wanted to send or receive in between your controller and your any of the slave device by using the cyclic communication. Okay, so in that scenario, in the advance, we have to do the PDO mapping. Okay, so if you see PDO mapping settings are available here. Another side again, this is the CC Link IE TSN configuration is there. So if I click on that now, you will see the PDO mapping. Batch settings of the PDO mapping option is available under the CC Link IE TSN configuration. Okay, so I'm just going to click over here. And then batch set pattern of the PDO mapping, yes. Then PDO mapping was completed, make it okay. Again, second PDO mapping is this one only. Go to the detail settings of this PDO mapping. Now we have to just check the things that whatever the link devices are here. Now you can see the 24 number of link devices are there. Okay, which devices where you wanted to use that pattern you can select by using this window only. Okay, so here it is the option, like you can select the patterns, how many number of points you wanted to use in that. Okay, I'm not changing anything, so I'm just making as it is, and then here okay. Okay, now this is the PDO map. Second thing is we have to set some servo parameters. Okay, we have to set some servo parameters. So if you see here, this is parameter automatic setting is there. Okay, so if like you have to enable this column, then first thing is if you enable this one, then only you can go to the detail settings of this one. If you click on this detail settings, then the window of MR configurator that will be open. Okay, that means in this network configuration, we are going to configure our servo amplifier, our MRJET servo amplifier in the one common network. Okay, here make it okay. So under that motion control function, motion tool, like under that network configuration settings, we are configuring our MRJET servo amplifier. So that's why from the parameter directly the window of MR configurator 2 is open. You can see here by default MRJET is coming here. That is our station number 1. Okay. So this is the parameters of our parameter list of MRJET. So suppose if you have MR configurator tool is available with you. So if you wanted to do the parameter settings or any test operations or any parameter settings, then single from the MR configurator tool you can do. But right now we are using the motion control software. So we have to do some parameter settings over here. And again, we have to come back to our motion control software only. Okay. So in this MR configurator, we have to do some settings. So first of all, we having one parameter is there. That is nothing but the first parameter, because right now I'm having some hardware, but in my side there is no any load. Only the single PLC with motion model is connected, and another side the servo amplifier is connected. Okay. So this is the four-stop declaration function itself. If you see, this is nothing but the parameter number. Sorry, this one. parameter number is PA04.2, that is nothing but the servo force stop selection. If you see here, na, if you make it enable, then you can use a force stop input, that is nothing but the emergency input is there. And if you disable it, then force stop input and output, input are not used. So right now I don't have another hardware, only the PLC side, PLC and motion module is there, and in the field side I having the servo amplifier and motor is connected. Okay, so I just make it disable. Okay, so that force stop selection is nothing but the one I'm selecting. Okay, now another side, input outputs are there, right? So in this side we are having some stroke limit functions. So like we have a limit switch stroke limit function is there, then sensor input methods are there. So here also you can see the parameter number PD41.2 and the PD41.3 is available. So first is the limit switch enable status selection is there. So here so we have to use one. It means the limit switch is going to enable only for a homing mode. Okay, only for homing mode. And this one it is PD41.3. This is nothing but the sensor input method selection. And here also I'm using one. That means we are getting the input from the controller. Okay, because right now I don't have another hardware, only the servo amplifier I'm using. So whatever the input is coming from the controller only, that input is coming from the servo amplifier only. Okay, so only the 3 parameter settings I am done. So first is in the common parameter number is the parameter number was PA04.2 is there, and in the input output side we are using the stroke limits. Okay, that is a PD41.2 and the PD41.3 itself. Okay, only this parameter settings we need to do, and just close this window, then you will get one pop-up. It is nothing but whatever the parameters you are going to change in the MR configurator, that all are reflecting in the network configuration in the GXWorks 3. Then make it yes. So now the parameter setting, or we can say the network configuration is done here. I will tell you again. This is our master station is there, and from this list I'm just taking MRJ80, that is nothing but our slave device. Just make a drag and drop over here, go to the configuration, do the PDO mapping, enable this one and do the parameter automatic setting. Through that setting, MR configurator window will be open, and in that only we have to do some required parameter settings and then close it. After closing the MR configurator, you will get a pop-up that every parameter it is going to reflect in the TSN network. So make it yes, and again come back to this window. After coming to this window, we have to close this window with the reflecting setting. If you are not closing with the reflecting setting, then whatever the settings you are done under this, that settings will be erased. Okay, so we are just going to close with the reflecting setting. Again, you are getting some warning, make it yes. This warning, just ignore that warning. This warning, it is related to the CC Link IE TSN configuration only. So I just close it, check and apply. Okay, so now settings for a motion parameter and the settings for a network configuration, these 2 settings are completed. Okay, now after completing these 2 things, we have to write the program in a GXWorks 3. Okay, write the program in a PLC. So first of all, just rebuild your program or convert your program, because before writing that compilation of the program is the must thing, and after that go to the online and then write PLC to PLC. Just select the program plus parameter, execute, yes, and yes to all. Okay, I'm just going to close this one. Okay, so just a minute. Okay, so this motion extended parameter settings are pending here now. So I'm just going to open the model extended parameter settings. Double click on a model extended parameter. So this is a window of a motion control setting function is going to open here. Okay, so you can see the version of this motion control setting tool. It is 1.055H. It is the latest version of this tool. Make it okay, because always make sure whenever you are going to use the motion model, then version of your PLC and motion model you need to check. Okay. Then here you can see the 000 starting address of the RD78G4 model it is. Then basic settings are there. Then system settings are there. Okay, so right now we have to go to the axis. So right now we are using MRJT, that is the MRJT-10G. That is a single axis supportive model it is. So I'm just going to right click on it and add a new data. And whenever I'm going to add a new data, you can see the data type, it is the axis. Okay, here there are some different data types are available, but I just wanted to add the axis over here, so I'm using axis. The data name is axis 001. I'm taking as it is. If you wanted to change that name, you can change it. Axis number is the 1. And then the main thing is the station address setting. So whatever the address, whatever the IP address of your servo amplifier, that you need to mention here only. So just click on these 3 dots. Now you can see 192.168.3.1 is the IP address of MRJT-G. That is actually connected with my setup. Then make it okay. Then the IP should come here. This access type, it is nothing but the real drive access it is. Okay, and this is the control cycle settings are automatically coming here. But if you wanted to change, then you can change it and make it okay. That means that single access you are going to add here. Now the whatever the parameters are related to that particular model are coming over here. Okay. Now you can see here, this is the axis number 1, then station address of this axis number 1 is the 3.1. Then there are some parameter settings also we need to do. Now ring counter is there. Just a minute, I will show you. So that limit you can able to assign as per your requirement. Okay, then value unit is there. If you want to change, just click over here. You can see the lead of the boss 2. I'm taking the 2 mm, so I'm taking as it is. The encoder resolution, it is by default for this servo amplifier. It is the 4194304 pulses per revolution. Then calculate as per the axis. Then you will get that ratio and make it okay. Another side, this is a drive unit configuration for a denominator. Change it, you can change or make it as it is. So the boss limit is the 2 mm. So you can calculate and giving you the some ratio, and you can see the numerator is over here. Okay, then make it apply. Okay, so now there are 2 things. One is the PLC is connected. Another side, our RD78 model is connected, right? So here also there are 2 working windows are there. One window is for GXWorks 3 for our PLC, and one window is for a motion control setting function is there. That means this window is dedicatedly work for a RD78 G4 model itself. Okay, so we have to write this both of the programs in both of the systems. Systems in the sense, one is for a PLC, one is for a motion model. Before that, I'm just going to initialize CPU. Right now, I'm just initialize my CPU because I wanted to clear the everything. Make it okay and refresh it. Close. Just and this one is my motion function there. So whatever the is available, first of all, I need to program. Okay. After it, go to the online and then write this program to your motion tool. Here you can see write to model. Then select the program plus parameter. So whatever the programming, whatever the labels you are using, whatever the parameter settings you are done in this motion control setting function tool, that only we are going to write in the our model, in our motion model. Make it okay. So writing continuous. Okay, so setting these parameters to the motion model is completed. Now again come back to our GXWorks 3 and compile this program also. Okay. Again. Okay. Now write to PLC. So whenever you are working with this motion model, first of all, do the parameter settings in a GXWorks 3 and in a motion model tool. Okay. So first of all, we have to write that parameters motion model, and after that, write the parameters in a PLC. That's it. So just give me a second. I'm just going to reset the CPU now. Okay. Fine. So the parameter setting and network configuration and some parameter settings related to the motion model are completed. Fine. Now another side here, that motion model, on that motion model, one Ethernet port is there. So I'm connecting that port, means I'm connecting the Ethernet cable from that RD78G4 to the MRJT. So MRJT is also having the one of the port is available. That is nothing but the CN1A port is available here. Okay. So if possible, that just give me a second. I will show you that one also. The setup is connected over here. Just give me a second. Anyone, can you please confirm me that my screen is visible? Yes, thank you, sir. Just a minute. It is not responding. Just give me a second. We have to do the some settings, some programming in this side in a motion control setting only, and after that we can able to write the program in a GXWorks 3 by using this labels. The system is getting hang, so just give me a second. We'll just wait for it. Here in the navigation window, if you see now, this one, so labels are there, na? Like global labels, local labels are there. So our the first task is we have to create some labels. So by using that labels only, we have to do the programming. Okay. And the main thing is whatever the labels we are going to create in this motion control setting tool now. So for example, here we are creating the global labels. So why global labels? Because the window of this motion control setting function, it is different one. So, and another side, the PLC window, that is GXWorks 3, is nothing but a different window, right? So we have to use the global labels, and after that we have to creating the global label and make it as a public. That means whatever the global labels we are creating, that easily we can able to access in the another window also. So that's why we have to create the global labels and we have to create it as a public labels. It is not going to open. Just give me a second. I will check it again. And I will close this window and I will open it again. Just a minute. Okay, I'm just opening that window again. This is our axis 1 that we have created. Okay, now come to the programming part. So if you see here, the different program bodies are there, like the initial normal program body is there. Okay, so and here it is, the labels are there. So global labels are there. So our first task is we have to create a labels. So right now I am showing you how to create a labels. So just go to the global labels, and first thing is we have to create a label here. But before that, we need to understand which program we have to write. So for this section, I have to write a first program. It is nothing but the servo on program I have to write. Okay. So now under the program body, here it is the normal program body is there. So I'm just going to create a one program body. So just adding the one. So you can see the data type. It is nothing but the program block. Okay, data name is the program POU. If you wanted to change, you can change it. By default, the programming language is the ST programming language. Execution type is the normal because we are writing a program in a normal program body and then make it OK. Okay, so this type of program body for ST programming, that program body will be open here. Another side, in this element selection window, we having a POU list. So in that POU list, under this administrative, you will see there are different number of blocks that are nothing but the built-in blocks or built-in labels are already available in this motion control setting tool. So right now, our first task is we have to write a program for a servo on, that is nothing but the MCV underscore power that is available over here. Just a minute. Sorry, that is nothing but the MC underscore power. See, you can see MC underscore power. This is the operation. This operation is available. So some of the built-in labels are there. Some of the built-in functional blocks are there. So either you can create as per your requirement, either you can use this some of the built-in blocks. Okay, so I'm having this MC underscore power is available here. So I'm just take here and just drag and drop over. Now at the time of drag and drop, you can see this label name, it is the MC power underscore 1 by default. So right now I'm using it as a local label. If you wanted to make it as a global, if you wanted to make it as a public labels, you can make it and you can register it as it is. Class you can able to change as per your requirement. So right now I'm using the variable class only and just make it okay. Okay, now you can see these nothing but the simple ST programming body is open for the MC power. Power means this is programming, we have to write it for a servo on program. Okay, so you can see the access is there, enable is there, servo on status, then ready status, busy, error, error ID. These labels are required for this particular program. So now another side, we have to create a label for this one. Okay, so now go to the local label settings again. Now you can see by default MC underscore power underscore 1, this label is coming over here. Now another side, we have to create a local label. Okay, so these labels are created because we are just creating the ST program in the normal program body. But whatever the labels we have to create, that labels come under this global labels only. Okay, under this global labels only. So first task is we have to create a global labels now. So first is MC underscore power underscore 1. Okay, that data type. Data type you can write here. Same data type is should be there. MC underscore power. Okay. Class. This is nothing but the variable global class itself. Another side you can see in front of this. The public label, it is right now, it is disabled, and another is the motion control attribute. Attribute in the sense, whatever the labels you are using, that labels you wanted to read, you wanted to write some data to the PLC or from that motion model. It depends which label exactly we are using. So this is the first label I'm using that I'm creating in the global labels only. That is the MC underscore power 1. Because if you see this ST, so MC underscore power 1, that label we require, then access, enable, servo on, this number of labels will be required. So for, as a background, in a global label, have to create that labels first. Okay, so now next label I'm going to create, that is the, for example, B enable. Sorry. Enable power underscore 1. Underscore 1 I'm giving as per my requirement. So if you wanted to change any bit, you can change it. Okay, then data type for this one, it is the bit I'm taking as it is. Then next I'm going to create label, that is the B servo on power underscore 1. Then next I will create it for a B status power underscore 1, make it yes. Again I am going to create a B BZ power underscore 1. Then again we required a B error power underscore 1, and last one it is our B error ID. This one it is not B. B I'm using, it is nothing but a data type, I'm using bit. So for my understanding I'm just taking the B, and here it is I'm taking the W because it's a error ID we are going to find here, na? Error ID power underscore 1, and for this data type will be a word, that is a word, unsigned bit is there. Okay, so for another side also we have to select the data type. Okay, so these number of labels I'm creating over here. Now in this side public labels, so we have to make it enable, because right now we are creating the labels in a global side, but we have to create it as a public, because in a PLC side we need to access that labels, so we have to create we have to make it as a public label. So I'm just going to enable that one. Okay, and then this is a motion control attribute. So in this motion control attribute you can see first one it is the MC power underscore 1 is there. Okay, another it's a enable power. Enable power, it means servo on power, it is right. So we are I am using a write. Write, it means we are going to write it to the servo amplifier. That means we are giving a command to the servo amplifier for a power on. Okay, second is servo on power is there, right? So again here also I am using a write attribute, and then after that whatever the status of the servo amplifier, whatever the error or any error ID is comes under the servo amplifier, that we need to read from the servo amplifier. So that's why I'm making it as it is, that is the read attribute I'm using. Okay, so whatever the write and read attribute, that we need to decide first. Okay, after that, see, after that, what we need to do? So right now I'm creating a labels in a global label. Okay, so we have to make it rebuild all first. Okay, so I'm just going to rebuild everything. So whenever you are rebuilt all everything, and in that you are getting any error or any warning, you have to check that one also. Any error you will find, then you have to clear it again. Right now I'm getting this error. Why? Because you can see this MC power underscore 1, this label is declared at a global level and a local level. So first thing is, see, whenever we are creating ST language, so this is by default one local label is created. So I have to delete that one from the local first, and then I can rebuild it again. Okay, so now this side local label, sorry, global labels are created, right? Now come to this our ST programming language also, come to this one again. So we have to complete this program by using that labels only. So for access we have some inbuilt labels are there. So I'm using that one only. Suppose this is the access one. So I'm using access 001. This is my first access. Then access reference is required. Okay, so these are the inbuilt labels. After that, for enabling, we are created the B enable label, that is a B enable. You can see B enable underscore 1 label is there. Then for a servo on, we are created B servo on label. That is a B servo on label is available. Just double click on it. And then for status, we have created B status. So I'm using that label only. And then for ready, we are using the B ready. Okay, I think I missed that. Okay. Again, go to the global levels and we have to write a one label for a ready also. Right. Here I'm using B ready power underscore one. So make sure we have to write first all the labels here. Then I'm just going to make it enable, and it's for this one also read attribute I'm using. Again, I have to rebuild everything because after this labels only I can able to use in a ST programming. Okay, now come to this ST language again. Now here we have to use the B ready power underscore one label. Then for BZ we have created BZ label. Double click on that. For error B error label we have created. For error ID, this is a word data type we are using. So for that B error. Okay, this one is different one. Again, I have to check for error ID now. For error ID, this is W error ID label is using. So here we have to use W error ID label. Okay. So in this manner, first thing is we have to create labels in the global side. After that, rebuild everything. Then in the normal program body of the ST programming language, here we have to use that labels and create our program for a servo on. And then again, I'm just going to rebuild everything because I need to check there is any error or not. So I'm just going to rebuild everything. Okay, so now rebuild is done. After that, again, go to the convert and you can see right now there is no any error, no any warning. After rebuilding, you have one option that is a reflect public labels, because right now we are using the global labels, but the same labels, with the help of that same labels, we have to write a program in a JXWorks3 also. So that's why I'm creating that is a reflect as a public labels. That means the global labels will reflect as a public labels. So in the another window also I can able to use that labels. Okay. Now these labels are working as a public in the JXWorks3. So again, I'm coming to the JXWorks3 window. So here you can see under model label. Now this is RD78G4 model it is. And here, first thing is here you have to check that labels are coming or not. Okay. So now here you can see the global label, whatever the labels we have created in a global label, that is a B enable, B disable, whatever that servo on, BZ, B error or error ID, everything that labels are comes under this only. Okay. Now what is our task? Our task is with the help of these labels only, we have to write a program. But before that, first thing is we have to write this program to the motion model. So again, I'm going to write to the model. Make it okay. Means we have to write a ST program, we have to create a global labels, and with the help of that global labels, we can write a ST program in a motion control model, and that you need to write to the motion model, and after that, that labels are reflecting in a JXWorks3. So in the JXWorks3, we have to use that labels again, and again we have to write the program to the PLC. Okay, yes, okay, close it. Now this program is going to write in a motion tool. Again, come to this GX Works 3. Here also the labels are open here. Now under the program, we have to write the one program here. We have to write a servo on program. So here I am using SM400. It's always on bit. Then as an input here I am using X1. It is a synchronous flag. Okay, and another side Y0 I am taking. It is a PLC ready bit. So this bit you should understand starting address of your actual motion model, and then that bit you need to select it. Okay, and after that again I am going to use SM400, and then for a servo power on we are using some labels, right? So you can see the label. So the first label, it is enable power _1. So here I'm using output. Okay, and that label address I'm giving, that is the, you can see, that is a B enable power _1. So with the help of that labels only, I'm creating a program here. Okay, and after enabling this, I'm giving input of enable only again. Make it okay. The same input I'm giving here, input side, and another side I'm taking output. Output is nothing but our servo on label we required here. Okay, so this is a servo on label is there. I'm dragging here also. So this is a simple 3-step program of the servo on. Okay, now again rebuild all. And after that again the same process, write to the PLC, execute, yes, yes to all. Only remember one thing whenever you are working with this motion model now. So first time, whatever the changes you are done in a motion side now, so just write it, that changes model first, and after that do the write to PLC. Okay, now writing is completed. Make it okay and close it here. Okay, now another side, my servo is getting on. Okay, I hope you can able to hear that voice. The servo is on now. You can see here also in the program the servo is on. So the program of the servo on is done now. Now the next step I will show you that about the jogging operation. So again, we have to write the program in the motion model side for a jogging operation. So again, I'm just going to the write mode again, opening that normal program body, and in that again for a jogging now, here also we have some built-in block is available. So here we have to find mcv _ jog. Okay, for jogging also the internal block is available. So I'm just taking this, here it is, just make it drag and drop, make it okay. Okay, so these are the labels are required for the jog operation. So again, our task is we have to create a labels for this all the jog operation. So you can see axis, for axis label is inbuilt. Jog forward reverse label we need to create. Then for velocity means it is nothing but the speed. We can create a label for it, or we can use directly a data register. We can change it from that one only. Then acceleration, deceleration, jerk is there. Okay. So if required, then these labels you can able to create. Or here it is the busy, active, then command. So for this all things now inbuilt some of the labels are already actually given, so we can use that one also. But the required three things are there. One is the jog forward, reverse, and the speed, or we can say the velocity that we need to give. So again, come to the global label, and here we are going to create the labels for a jog operation. Okay, so here I'm using axis 1 underscore jog, F means forward, then axis 1 underscore jog reverse, and then for velocity I'm using the label that is the axis 1 jog speed. This one is I'm using this labels for my understanding. So here it is, we have to set the data type first. For a jog forward and reverse you can use a bit data type, and this is the speed. Like we have to assign a speed for the jogging purpose, so we can use here the floating data type. So here I'm using floating data type, and for this one again we have to enable this all the things, enable, and here also enable. Okay, and this is, you can see for the jog forward, reverse, and speed we have to give the attribute of right, because we are giving from our software to the model. Okay, after this again come to this our structure text. In the background the labels are created. Now here we have to give the label names. So before that, just rebuild everything. Okay. So now here, again I'm going to rebuild it because we need to remove all the errors first. There is one syntax error actually. So now here, so first of all, we have to write it again. I have to check that syntax error first. Okay. Now here I'm going to use some of the built-in labels, that is axis 1 dot axis reference. And here jog forward and jog reverse label we have to use, that is axis 1 jog forward, then axis 1, sorry, axis 1 jog reverse label we have to use. Then for velocity you can use right now I'm using that label axis 1 j speed label I'm using. Instead of that, if you are giving a fixed speed, okay, you can give a fixed speed also, so you can give that one, or you can use a label. Then acceleration I'm using, that is a 1.0 I'm using by default. Jerk also I'm using the same only. Then in the option I'm using 1. So for done, there are some built-in jog done bit is there. So I'm using jog dot done. So you can see built-in labels are there. I'm not using separately. For a jog 1 is busy. So first of all, we have to write the program here first. For a jog 1 means axis 1 jogging operation. And for this one also we have a built-in jog 1 dot command about it. Then for error, that is the MCV, that is jog 1 label dot error. And then the last one is for an error ID dot error ID. So in this manner, we have to write a ST program first. Now again, rebuild everything. Okay, after rebuilding, go to the convert and do the reflect the public labels, because the first task is nothing but we have to reflect it to labels. Public labels. Okay. No any error. Again, reflect it to the public labels. Okay. Reflect. See, jog one now. Editors. So other side again in the PLC side in the GXWorks 3 we have to write a program for the jogging by using that forward reverse labels. So I am just using internal bit and as an output I am using axis 1 label. So this is axis 1 jog operation label I am using. Here I am using M1 output, make it okay. And this is the jog forward label we are using. Then for a speed. So here using ED move instruction that is nothing but by default 32-bit instruction. So E because we are using the floating point data type. So here the D100 data register I am assigning and as a destination here I am using a speed. So this is the axis 1 jog speed I am assigning over here and then rebuild all. Once you have to write it to the PLC. Okay, it takes some time. Okay. Because it is not only going to write the program and parameter of the PLC, but also the motion model also. So that's why it will take some time. You can see standard parameters are writing now. So writing is completed. I'm going to reset the CPU. Okay, I will come to the read monitor. Mm. Okay, servo is now. You can see here it is D100 data register I'm using. So in the watch window, we have to give the some value. So I'm using the D100 data register over here. Data type will be the floating data type. And we can do the start watching and we can give some values over here. For example, I'm using this one only. So you can see. So first my task is I have to give speed. Okay. And after that, we can do the jog operation. Okay. So for your concern, I'm just showing you my camera again. Just give a second. I hope is it visible now. Here you can see motor is in running state. Okay. Now this side, if you stop it and give you the reverse, now you can see the motor it is running in a reverse state. Okay. So in this manner, the motor we can write a program in a motion control tool, and that labels can reflect in a PLC side, and then we can easily control our amplifier. We can control our motor through the jog operation. So similar way, we can do the things just like the homing and positioning. Also, there are as the some features are there. We can do this interpolation, linear interpolation, circular interpolation, synchronization through this one only. Okay. So the thing is, here we are just using the motion control tool, that is the motion control setting tool we are creating. In the background, we are going to create a global labels, and with the help of that global labels, and also there are some built-in blocks are there. With the help of that one only, we are creating a program here, and we are just reflecting all the labels as a public label. So easily that labels we are going to access in our GXWorks 3 window, in the navigation window. Okay. And here only, and that with the help of that labels only, we are going to create a program over here. Okay. So through that we can easily control our axis. So the servo on and the jog operation is completed here. So as of now, the positioning homing functions is remaining, but as you know, like we have some dedicated time limit. So this is the thing. I'm just showing you that the jogging and the servo on operations. So this is the scenario how to do the parameter settings under the GXWorks 3 and under the motion control software, and this parameter settings and everything. So up to this, if you have any queries, any issues related to this, you can put your questions in the chat box. You can raise your hands. Okay. So it's very better that you can put your questions in the chat box. So anyone have any questions related to this, you can please put it here in the chat box. Okay, so no any questions related to this? Fine, so no problem. So thank you everyone for attending this session. So in this outgoing session, like any issues, any network issues are there now, please understand. Okay, so thank you everyone for attending this online session for the RD motion, RD78G4 motion module that configure with the our MRJAT. Same, instead of MRJAT, if you have MRJ5 also, you can configure the same process. Okay. So thank you everyone for joining this webinar. So now we can conclude this session. So thank you everyone. Yeah, I'm getting one more request to sharing that recording. Yes, definitely, sir. But before that, I need to check with this IT system, and then we can share with you definitely. That every document I need to check with the IT team, because this is an online platform, that how I can share with you everyone. Okay, so if it is okay for that guys, then I can share with you soon. Okay, so thank you so much. Yes, one more question is how to open element selection. Sir, element selection window, it is available in a view. If you go to the view, here only, if you go to the view, in the docking window, you have the element selection window is there. Okay, so under that element selection window, you have to go to the models only, and in that models, you will find out the labels. Okay. Okay, fine. So we'll just conclude the session now. So thank you once again for attending this online session for the RD78G for motion model. So in that, like if you have any doubts, you can mail me on our common mail ID. That is the FID mail ID is actually available with you only. So you can put your queries over there also. Okay. So we'll conclude it now. Thank you so much everyone for attending once again. Thank you.